Hello, everybody. Good morning, good afternoon, and good evening from wherever you are. My name is Kenzie. I am a specialist solutions architect that specializes in AWS Elastic Disaster Recovery. I've been with AWS for about 4.5 years now, and my primary job is to work with AWS customers in protecting their critical workloads in a means of using disaster recovery. And today, I'll be talking to you on how to leverage Elastic Disaster Recovery to build scalable, cost-effective DR to AWS. Some housekeeping things to go over is the agenda. I'll be talking to you why we use cloud-based disaster recovery, some common disaster recovery challenges that I see, and how does Elastic Disaster Recovery works in AWS. Later on, I'll be showing you a demo of how it works, and then some customer success stories, and then some resources that you can take away with. So, one of the first things, why use cloud for disaster recovery? In the beginning, early of my career in IT, I worked with an organization that needed disaster recovery, a new disaster recovery for their site. The reason is, the business is moving very fast, and for other reasons, they needed another disaster recovery location. During that time, I remember that we had to source a location, the new disaster recovery data center. And then once we source a location, we have to take a look at the floor space. And then we have to take a look at some of the power and cooling equipment that they are using. And then once we decided that we want to choose one, we have to figure out the lease. The next step of that journey to create that disaster recovery site was to look at some of the equipment that we'll need. Some of the SAN storage that we'll need, fiber channel, the amount of networking equipment that we'll need to get this site running. And then after that, we'll probably have to figure out the procurement of licensing, some of the software that needs to be installed onto some of those servers. Now, all of that you just hear is pretty typical if you are building out a data center, some of the leasing, some of the equipment that you'll need to have that working. Now, I'm not going to say that cloud is going to alleviate all of that, all of those headaches. But one of the biggest things is that you can think about when we're using cloud as disaster recovery, it will eliminate a good chunk of that, of some of the equipment upfront costs that you'll need to pay. Leasing, sourcing a data center, having that SAN storage that you'll need to put in, and then having that, ability to figure out, how much we'll need, because for the cloud, it's kind of a pay-as-you-go scenario. All right. Now, how is disaster recovery different from backups? I remember once there was a manager that I had, he told me that, disaster recovery is kind of like life insurance, right? It's life insurance for the IT department, for things that need to be up and running very quickly, but sometimes backup is just good enough for the business need, right? If we need to recover some of the data, we can recover from disk, from somewhere backup of the disk. If that data is somehow missed, the backup missed it, or it's corrupted, we can always go as far back as some of those LTO tapes that we can pull from, and then maybe it could take days to get the data recovered. But in this day and age, does not cut it anymore. If we think about it, in disaster recovery, it doesn't just recover just the files. We're recovering the entire application and the system state. Not only that, the recovery time of those data is within minutes instead of hours or days. Some of the cloud-based disaster recovery drivers that we see, as I mentioned early in the beginning, when I was talking about how building out that data center, there is a lot of cost associated with it. All that upfront equipment that you'll need to procure, licensing costs, all of those headaches that you need to think about, definitely reduces the total cost for ownership for having that disaster recovery site. The other thing is also improving the business needs objectives, such as the recovery time of some of the systems, right? As I was mentioning in the previous slide, we're talking about, if you have backups and then compare to the DR, but, having a DR and lower costs is probably a great win to be able to move your data into AWS. Now, some of the common disaster recovery challenges that we see. Most of the time when I start talking to customers, first thing I'll ask them is, how often are you able to do, testing for disaster recovery in your environment? And to my surprise, many of the customers will typically say, they've tested maybe once a year. The good customers, the ones that have to stay compliant, they will test it every quarterly, which is very good. And then there are some of the customers that I talked to where they said, oh, we never tested it ever since we bought DR. So it's just idling equipment sitting at the DR site, not doing anything. And we understand that, right? We see these kind of challenges because not only is it that you need to, have the ability to test this, but the people and the key stakeholders that are running these DR tests, we know they are busy. Whether it's a DBA, the SAN administrator, or the network administrator. Having all of these teams group up together and be able to come together and be able to execute the DR plan that you have created can be a challenge. So those are some of the challenges that we typically see when we're working with some of these customers. It's not only just the cost, but it's also the people that are working to overcome with these DR challenges. Now, how does Elastic Disaster Recovery benefit or help alleviate some of this? We have 3 key pillars here. Flexible. One of the first thing is flexible, reliability, and highly automated. With the flexibility pillar that I was kind of talking about, one of the best things is you have the ability to replicate from any source, whether it's a virtual environment, a physical environment, or even a different cloud provider, and replicate those data into AWS. The second thing is it also removes the need of having those idle equipment sitting there. As I was mentioning before, when we have a data center that's just idling there that the customer was not using because they haven't had the ability to do any testing, having this flexibility to not have those idle resources can save you money. The next part about the reliability, because we are performing block level replication, it's very non-disruptive and it's continuous. And also, as I was mentioning before, with disaster recovery, you are able to recover your data within minutes, not hours, not days. And finally, highly automated, right? You're leveraging the power of AWS in the cloud. One of the best things is you're able to build on top of different automations that can be worked with. Some of these automations can be such as Resilience Hub, using AWS Systems Manager to create those repeatable testings and understanding if this DR is working. Now, this is probably an interesting one, right? We know there are customers that may not be ready to go into the cloud, right? We know there are those customers that, hey, I like to have my workloads on-prem. We like our production on-premise. We have full control. We don't want to move it into AWS. We get that, right? We understand that. But here are some of the benefits. If you were to save on your tech refresh, let's say that equipment in your DR site the lease is coming up, and also the equipment that's there, it's starting to depreciate, and it's time for a tech refresh. Why not save that cost and just move the DR site into AWS, and you can keep your production workloads on premise if you like. Second component here is the migration. We know there are those other customers that are ready to go into AWS, and they're using awesome AWS MGN service to migrate all their workloads into AWS. Hey, why not, now that we have the ability to go ahead and increase your resiliency for those migrated servers? We have a new ability to enable disaster recovery, DRS, once those servers are migrated into AWS for AZ to AZ or even cross-region DR. Now, I'm not going to go too much into this particular slide, but we're kind of talking about, the life cycle of the Elastic Disaster Recovery, right? From the beginning, you definitely going to have to look at setting it up, right? Installing that agent on your servers, whether it's Windows or Linux, that's sitting on block storage. Once you have that, you decide which region you're going to be going into. You have the ability to go ahead and start doing your building out your tests. Right. In the testing later on in the demo, I'll show you how we're going to do some of these test drills within your AWS Elastic Disaster Recovery environment. And then also after you've done your testing, it's just your day-to-day operation. All right. Some of the monitoring I was mentioning before about AWS Systems Manager that can help monitor your day-to-day operation. And you have the ability to perform a failover within minutes of your servers. Once you have your, let's say your on-premise, your primary site is back up and running, you have the ability to go ahead and perform a fail back, which allows you to go ahead and restore your data back to your primary site originally. So that's kind of the life cycle of a typical Elastic Disaster Recovery from beginning to the end. Now you're probably asking, Ken, how does all of this work, right? If we take a look at this, this is kind of our architecture diagram. One of the key two components that I want to start with is on the left-hand side, we have your traditional data center, whether it's physical or virtual environment or another cloud provider. On the right-hand side, you have your AWS cloud. Within the cloud, you have your different AWS region. And this DRS service runs within each of those regions that you choose to use it in. And then within the regions, you have your VPC, and then underneath those VPCs is broken up into different subnets. Now that we have those concepts down, let's begin. First step is we definitely want to choose your region. So let's say you chose US East 1. You would choose that region, have that all set up in the AWS. Once you have that set up, next thing is going to go ahead and install the agent. When you install that agent on your source machine, as I was mentioning before, whether it's Windows or Linux, as long as it's sitting on block storage, we are going to go ahead and be able to perform that block level replication into AWS. Keep in mind, it is continuous block level replication. So any changes that's happening on the source will get replicated to AWS. Now, when I'm mentioning here, where are we replicating into, Ken? If we can see here in the middle, there's that staging area subnet. We pre-create a staging area subnet. Think of this as your depository, your repository. This is where all of that data is going to be replicated to. And if you notice, there is what we call replication servers there in the middle. These replication servers are basically sitting there to intake that traffic of data that's coming in from your source and into AWS. One thing to note, in order to keep costs as low as possible, we are leveraging what we call a T3 small instance. The T3 small instance is powerful enough to, to take all that ingest of that data. And then when we're ingesting that data, we are creating EBS volumes. Now, there is a target line of costs. We are leveraging EBS volumes when we are in that staging area. There is a ratio that I would like to remind you of, is there is for every 15 volumes that is replicating from the source, we will only spin up one T3 small replication server. So for example, if we have 3 servers and each server has, let's say 5 volumes, that's total 15 volumes, you will only need to spin up one T3 small replication server. Now, I forgot to mention, in this staging area, these replication servers is all controlled by DRS. You don't have to manually spin these up. In the control plane, the DRS will manage these replication servers. We will spin them down or spin them up whenever it needs to be. Now, in a sunny day, everything is great. Right here, this is it, right? This is where everything is working. It's perfect scenario where you have changes on your source. It's going to go ahead and replicate the latest data over into AWS, and it's just sitting there dormant. It's not using a license. It's not spinning up high high compute performance, high memory. It's only using EBS volume. It's not using provision IOPS volumes, and it's just sitting there, just humming along until there is a time where a disaster happens, or if you need to run any sort of test drill. Isolated testing is one of the biggest thing we always tell our customers to run as kind of a best practice. Within AWS, you have the ability to create multiple subnets, and then with these multiple subnets, you can isolate that environment when you're spinning these resources up. So in a scenario, let's say you want to do a testing. What is going to happen is you'll invoke that in the DRS service. We will go ahead and choose based on, we'll spin up these resources based on what we call an EC2 launch template. Think of this EC2 launch template as kind of your playbook, telling you what type of server, or what type of instance you want to spin up, what type of networking you want to attach to it, IP address, the type of security groups you want to apply, and then also what kind of AWS tagging you want to apply to that particular server, and also even type of volumes, provision IOPS, SSD, you name it. Once that launch template has been created, DRS will use that to spin up the server that you designate that to, and spin it up within minutes within that recovery VPC. Once that recovery is done, you can essentially be running your production, in your DR environment in AWS. Or if you're doing an A/B testing or some kind of a testing environment, you can go ahead, once your testing is done, you can remove those resources. Now, talking about it is great. Let's go ahead and show you how it actually works. We'll go right ahead and go into the demo. All right. Now, as we can see, we are in my AWS console. Now, some pre-work here has been done to this. I want to mention that I have set up, or I've selected my region for the Elastic Disaster Recovery service. Right now, I have selected Oregon, US West 2. For this particular service, I've chosen this for my DR site. Another thing I've set up is also I've already created a particular role, because when you're setting this up, you need a specific role that you need to create. I've already done that. The next thing I want to talk about is I've already set up some of the security groups, created that subnet, that staging subnet that we were showing you before in the architectural diagram. And I've also created a target subnet, just to put those servers in when we are launching later on. So one of the first things, let's take a look at the Elastic Disaster Recovery console. So for my console, up on the top search bar, essentially, I would just type Elastic Disaster Recovery. And as you can see here, it already shows up. I'll go ahead and click. And as you can see here, this is the Elastic Disaster Recovery console. From where it starts, I do have 52 servers currently being protected with the service. So we can kind of see here in this screen, I have some of these servers already set up. And if we want to go into the settings, some of the replication settings, as I was mentioning before, the default replication server, is using a T3 small. And if we can see here, T3 small is already been configured here. I've already, as I mentioned before, already created my staging area subnet, which is already here. Some of the volumes that's going to be using are using some of the defaults that I've set up. Any routing that has been done is also going to be set up in here. And one key to note here is by the default, the point-in-time recovery is 7 days. But this can change based on your business objectives. So if you want a longer retention point-in-time period, such as like 2 weeks, you can change that and set that up here. Or because you may have backups and you may want to lower that retention period, you can do that as well to make it a shorter period. And then you also have the ability to set up key tags down here at the bottom. Now, let's go ahead and do the first thing. I want to be able to show you guys how we're going to be able to install the agent on and get this running. We'll first go ahead and log into my Windows server. Now, as you can see here, I've kind of done some prep work to get this in, to ensure this demo runs a little more smoothly. I've already downloaded the DRS replication agent, the executable, on this particular server. So that's already pre-downloaded. I've also created the already got the IMA roles access key and secret key information just to speed up the demo of this installation. So when we're going through this demo, we already have some of that already, kind of make it easier or smoother access. So let's go ahead and start the installation of the agent. Right now it's going to go ahead and start. And as you can see here, asking us our AWS region. So we'll go ahead and choose US West 2. Now it's going to ask us for the access key. Go ahead, choose that. And then we have our secret key. I'm going to go ahead and take a look at we have enough space on the volume. And then it's going to ask me if I want to replicate all the volumes. I'll just go ahead and say OK. Now it's going to go ahead and download the Elastic Disaster Recovery agent onto this particular server. And that could take a few minutes. Now, as this is being downloaded and being installed, you may notice that I'm installing this very one at a time, right? If I have multiple servers, this will not typically work. We have the ability to wrap this up into any sort of automation for you having the ability to install these agents at mass. So majority of our customers that we see, they'll probably tend to use some sort of a group policy to push these agents out to all of their servers. Or if you are already in AWS, you can use kind of like that systems manager to help push out some of these agents for the installation. So that way you don't have exposed keys. Everything is all kind of set up, and it's just going to get pushed and installed there. And as you can see here, it finished downloading the agent, and now it's going to go ahead and continue with the installation. Now it's syncing the source server with the console. And if we jump back over to the console here, and if we go ahead and hit refresh, we may see now that we have 53 servers. And there it is right there. That's the DB server that I am replicating. Now it's performing the initial sync. So it's going to go ahead and read all the blocks that's sitting on that particular server. I believe it's about 30 gigs in size. If we take a look here, it's gathered some of that information. We already seen number of the size of the volume, total time currently that it's been replicating. And as you can see here are some of the initiation steps, right? That it's going through. As you can kind of see, if you want to have any kind of event or metrics, you can actually use CloudTrail to kind of build that. And we go ahead and, well, if we wait, that may take a few minutes. So we're not going to go ahead and wait. We're going to go ahead and take one of my servers, and let's take a look at let's take a look at this one ending with 222 at the end. So as we can see, it's ready for recover. We have finished the replication. The job is completed. We can see that we never tested this. So this job has never been tested. The server is a blank slate. We take a look down here further, replication status, total of 8 gigs data. It's been totally replicated. And we go up here, the server information. You can kind of see some general information about the server, some of the ID information, host name. If we take a look at the hardware, as we can see here, what kind of CPU and RAM that we are running, and also the volume that is attached. And we go a little further down here, we can also see the operating system. It's Linux that is installed on this particular source server. And finally, we can see the recommended instance type. As you can see here, it's a C5 large. This is recommended by DRS. However, I do recommend that you go through a sizing exercise and ensure that the current CPU that you are using kind of, is if it's more than what is recommended or if it's less. I would highly recommend definitely go through and make some of those changes that is needed. So let's go ahead and make those changes. Instead of choosing a C5 large, let's go ahead and make those changes that is needed to be. We'll go ahead and go into launch settings. One thing that we do want to turn off, if we can see here, is the general launch settings. So general launch setting is kind of a quick way of getting you started. It's going to go ahead and determine a EC2 instance size for this particular workload, and it's going to go ahead and choose some of the default settings and to kind of get you started or go. But what we want to do is go ahead, because we want to choose our own instance type, we'll go ahead and choose none over here, and then we're going to go scroll down and hit save settings. This way we're going to go ahead and choose the more advanced way of editing this and choose our own instance and choose our own networking security groups that we want. So as you can see here, this launch template particularly is using a C5 large and is using provision IOP volumes, but I don't want to use those. Let's go ahead and hit edit and make those necessary changes. All right, so as you can see here, very familiar. This is the EC2 launch template screen of modifying a template. I'm going to go ahead and name this version 5, just for simplicity. And we go down here. We don't want to choose any particular AMI, and I want to choose a particular instance type, right? C5 large, it's a little bit costly, a little too expensive. Let's try a T3, right? We were all using T3 smalls. Let's go ahead and let's do a T3 large that we have here, T3A large. A little bit more expensive, but let's go ahead and choose that. T3A large. Next thing, in this template, if you want to choose any particular key pairing, you can choose that here. Networking setting, right now I don't have a subnet selected. I'm going to go ahead and use one of the subnets that I've already pre-created called target. Next, we can select a security group. I also have created a target security group, and I'm going to choose that here. One thing, as you're going through this, you may skip something, which is very important. It's called the Advanced Network Configuration tab. If we click open this, you do have the ability to add additional components, such as an ENI. If you want to disable public IP address, you can set that up here. And also the ability to choose whatever IP address you want. When I say you want, it basically your boundary based on your subnet and your CIDR block range. So, choose wisely, right? That you can pick here. If we go through here a little bit more, configuration of the storage, I definitely don't want you to use IO1. I want to use GP2. It's a little bit costs less. And any resource taggings, I'm just going to leave those as default, but I can add additional ones if I want. If I go into advanced settings, these are some of the more advanced settings that you may or may not use, such as request spot instance instead of on demand, choosing different type of instance role. You can also choose the type of behaviors during the shutdown, termination protection, when you stop this instance, what it can do, and all these other different. You can also enable CloudWatch monitoring that is in here. And then as we keep going down, different Elastic interfaces that you can add. and much more. There is a lot of configurations that you can actually go through and make the changes. But for now, the biggest thing is I definitely want to use that target security group that I created, and I want to use a T3A large instance type, and then we have the 8 gig of volume. So let's go ahead and create this template and save it. Now it's going to go ahead and we want to go ahead and view this template, right? One of the things is with DRS, by default, if you notice, it did not change that to the T3A that we wanted. But in DRS, by default, it only uses the default launch template that is set. So if we go back into there, the default template is the C5 large. What we're going to do is we're going to copy that template and find it here. There it is, the one we just created, and we'll select it. We'll go under Actions, set the default version, and let's just choose the one that I called version 5. So as you can see here, the default, that's the one that was created by the DRS service. We want to choose version 5. Let's go ahead and set that default version. And it has successfully, if we jump back over here, we should see this to a T3A. There we go. Now let's go ahead and launch this. We'll go ahead and initiate a drill. Now, remember in the beginning I was mentioning about all the different point times. This is where you will be able to select that. As you can see with the most recent data, it's anywhere between 5 to 45 seconds. And if we scroll a little bit further down, all of the different type of point in time recovery times are every 10 minutes for the first hour. So as we can kind of see here, it goes down to every 10 minutes. And then after the first hour, it will be after the first hour, it will be additional every hour for the next 23 hours. And as we take a look at page 2, we have additional point in time recovery for every single day for the next 7 days. But for now, let's go ahead and choose to use the one from 10 minutes ago. We'll go ahead and click Initiate Drill. And we shall start seeing this job going. It should take a few minutes for us to launch this particular server. Go ahead and click on Job Details. And we can see that the conversion has started. Let's go ahead and take a look at the EC2 console. While that is being spun up, we can see what is going on. We go ahead and click on Instances. Now, as you can see here, there is all of those T3 small replication servers that I was mentioning. I got about 50 somewhat servers, but I'm also running different configurations. So that's why we see so many replication servers. Don't be alarmed. This is normal. These will get spun up automatically up and down based on the load that you need and also the volume that you have. So as you can see, some of them get terminated, some of them are running, so they all get spin up and down. One thing we'll notice here is that there is what we call a machine conversion. This particular server is running, let's say, it's running on VMware. And because when you are replicating a server into AWS, it doesn't just boot up as an EC2 instances. The DRS service has the ability to perform a machine conversion that converts these particular volumes into bootable EC2 instance. We'll inject the correct drivers that is necessary for these servers to boot up. So that is why you'll see a machine conversion server that is being spun up and looks like it's being initiated and being performed to run right now. We go refresh. We can see it also being stopped. So it looks like the conversion process has completed. So that only takes a few seconds. And if we go back to the other tab, And then we refresh this. And as we can see here, that the conversion is completed. Now it looks like it's starting to launch that recovery instance. And if we go back to the EC2 management console and we refresh this, we should start to see a T3A large being spun up. And there we are. There's that particular instance. T3A large currently is going to be booting up. And we jump back over to the DRS page. Wait for a few more minutes here. And just like that, within a few minutes, looks like the job is completed. So if we go back to the EC2 console and we hit refresh, we should see that particular server be initialized and up and running. So that concludes our demo of the DRS service. I hope that gives you an impression of how the service works, brings you in a little bit more insight as to how some of the configurations are done, and also give you the ability to see some of those replication servers and how easy it is to use EC2 launch template to create your own custom launches for those particular server. Now that I've shown you the demo, I just want to briefly touch a little bit some of the feature updates that we've added into this particular service. One is notably on the Elastic Disaster Recovery side, we've added additional 12 additional regions to the service. There is more to come later on, so stay updated with us to know that. The ability to support multi-staging staging and target accounts. What that means is within AWS, there are certain API limits because we are creating snapshots, we are spinning up servers, we're spinning down replication servers, we're doing replication of the volumes. There is a very heavy load on some of the APIs. And AWS limits certain APIs for specific for accounts, right? So once you go over that limit, you're going to be throttled and not be able to essentially do anything. But giving that support of multi accounts, if you have a large environment, let's say more than 300 servers, it's kind of a best practice to create multiple accounts specifically dedicated to your staging area. So when you are launching machines, they don't interfere with the APIs that's being run on the staging area. Support for automation failback. If you're going back to a VMware environment, we do have the ability to perform an automation failback. That's leveraging our mass failback kind of an appliance to perform failback. The AWS MGN migration service now currently supports configuration of DR. As I kind of mentioned a little bit earlier, once you are post-migrated into AWS, you do have the ability to enable DR right after the migration. So which is great, and as long as you've configured your DRS service, you can enable that right after your migration. The ability to convert CentOS Linux to Rocky Linux, to give you the ability to do that, convert SUSE Linux to a subscription base for those MGN service. Can't leave you guys without kind of showing you the wide support or reminder of all the different platforms we support. So remember, it is a block level replication. So it doesn't matter what database, what application is installed, we are going to be able to go ahead and replicate and copy those data into AWS. The next component is, long as it's sitting on a block storage and it's running on x86 operating systems, so your flavor of Linux and Windows, we will be able to support that. And also, as I mentioned in the beginning, any infrastructure for your source. As long as your target is within AWS, we support anywhere from physical data centers, Hyper-V, VMware, and even other cloud providers if you want to protect those workloads. Now, before we go, I want to share with you guys some of the success stories. with some of our customers. One of them is Malibu Boats. They are one of the world's largest manufacturers of high-performance sport boats. And the story with them is that they were actually shutting down one of their DR data center to save costs, and they were looking towards AWS to do that. They leveraged the Elastic Disaster Recovery service to perform disaster recovery of their on-premise environment up into AWS. And one of the things that they mentioned to us was they had a disaster on-premise, and they actually spun up their servers and recovered the servers in AWS. And what they found out was when they ran it in AWS, it was 2 times faster in performance than what it was running on premise. So it was kind of a no-brainer for them to just keep running operation in AWS, which cost a lot less, and it was better performance. So this customer actually, were not ready to go into AWS, but they leveraged DR. But now they kind of got got a taste of the performance that AWS can deliver. They actually continue to run the workloads now in AWS there. Now, for this next case study, we have Thomson Reuters. This is a news and information service company that provides solutions for tax, law, media, and government across about 100 countries. This particular business unit that they have called OneSource GTM helps their customers meet compliance for their imports and exports through their software. And one of the biggest reasons they selected AWS's Elastic Disaster Recovery was the easy-to-use automated service that can be deployed quickly without the system disruption. And also meet some of their stringent recovery point objectives, and also help them minimize the downtime and data loss. Now, I want to provide you, some of the resources here, right? How do we want to get started into this? Definitely, first thing you want to visit, if you have AWS access to your AWS console, definitely search for Elastic Disaster Recovery in the search bar on the top left, and that way is to get you started and actually see the console in person and get to play around with it. Next thing you want to do is definitely contact your account team. They are definitely one of your frontline defense of understanding new services, where they can show you things. Bring in specific team like myself to come and show you how this works. And we also have a plethora of our partners that we have. We do have specific partners that that are custom to perform disaster recovery, that are trained in the Elastic Disaster Recovery service, so they are able to help you in that area. And finally, having the ability to, take some free online classes training to understand how these works through the AWS skill builders. And we have here just some resources that you can take with you to kind of understand, visit some of our product pages. Definitely use the console to start replicating server, understand it. It's those free technical trainings that is there. And then we also have, documentations, and this particular service is also supported by premium support. So that concludes our presentation for this tech talk. We will start taking your questions. We also have a couple of my colleagues here to help, so don't be surprised if you hear another voice to help answer some of your questions there. Thank you.